How Tesla's battery mastermind is tackling EV's biggest problem. The lithium-ion batteries are used in a wide range of devices, including computers, notebooks, tablets, cameras, and, increasingly, automobiles. Lithium-ion battery demand has grown dramatically in the last 5 years, with the industry forecast to increase from $44.2 billion in 2020 to $94.4 billion by 2025, owing largely to the growth of electric vehicles. In addition, a lithium-ion battery crisis is looming in the United States. They contain hundreds of kilograms of metal and materials, especially graphite, cobalt, and high-purity nickel, which can pollute the environment and increase CO2 emissions during the mining and refining process. Another issue is safety. These batteries are vulnerable to catching fire and exploding. The hype around solid-state batteries, a much-touted invention that hopes to address all of these environmental and safety issues, is understandable given these disadvantages. The next-generation power source, which gets its name from the thin coating of solid electrolytes that replaces the flammable liquid solution in current lithium-ion batteries, will store energy even more densely. The electrolytes also serve as the separator for the battery, a critical part in a lithium-ion battery, minimizing the chance of fire and the amount of raw materials used. J.B. Straubel, the former Tesla CTO and Elon Musk's right-hand man, founded Redwood Materials in 2017 to meet the need for more raw materials and to tackle the e-waste crisis. As global EV demand surges, the company recycles end-of-life batteries and then provides battery manufacturers and car producers with products in short supply. Straubel gave CNBC a tour of the company's first recycling plant, which is located in Carson City, Nevada. Tesla's aim is to hasten the world's transition to renewable energies. On September 22, 2020, the corporation unveiled a series of initiatives aimed at lowering the cost of electric vehicle batteries while increasing their spread. With regards to our energy transition outlook to 2050, we analyze whether Tesla's Battery Day updates will progress the company's goal. We expect a rapid energy change, marked by a more than doubling of electricity in the energy mix by 2050, as outlined in recently released Energy Transition Outlook 2020. We estimate that by mid-century, more than 60% of that electricity would come from intermittent renewable sources, solar PV and wind respectively, necessitating a significant amount of storage to provide reliability and resilience to an energy grid dependent on variable sources of power. As a result, advancements in battery storage are crucial, and Tesla's advances, which are summarized below, would have a profound impact on future technologies, not only in the adoption of electric vehicles, but in the entire energy sector. Battery costs are expected to drop by 19% with every doubling of installed capacity over the projected period. Based on an estimated cost of $156 per kilowatt hour in 2020, decreasing to $80 per kilowatt hour in 2025, our prediction shows global battery capacity additions of 430 gigawatt hours, or GWH, in 2020, rising to nearly 4 terawatt hours, or TWH, in 2025. This is one of the key reasons for our forecast that by 2032, 50% of new passenger car deliveries will be hybrid. Tesla unveiled a bundle of technologies on September 22nd that will be introduced over the next 2 to 3 years and will slash the cost of batteries by 56% measured in dollars per kilowatt hour, increase coverage by 54% per kilogram of battery, 69% lower investment cost per kilowatt hour of production capacity. If it meets its targets, Tesla will almost definitely be the world's most cost-effective lithium-ion battery manufacturer, accelerating our battery deployment prediction. It essentially marks the demise of the internal combustion engine, which has major consequences for the car industry. The media reaction to Tesla's Battery Day announcements has left CEO Elon Musk dissatisfied. The need for faster charging times and greater range without raising battery pack costs or increasing the risk of fire has reached a technological limit. Solving these issues is critical to the electric car revolution's success. Solid-state batteries have a partial solution, but they may jeopardize Tesla's status as the undisputed industry leader in terms of vehicles sold. With a $1.8 billion payout and an unspecified rolling royalty deal for the domestic manufacture of batteries for electric cars, South Korea's 2 leading lithium-ion battery cell manufacturers have decided to resolve their legal dispute on U.S. soil for EVs. Both companies have since committed to withdraw all existing lawsuits in the United States and Korea and not assert any further claims for the next 10 years. After LG Chem alleged SK Innovation misappropriated trade secrets from the firm, the International Trade Commission, ITC, sided with LG Chem. Emerging US-based EV producers can breathe a sigh of relief. The International Trade Commission, a US trade agency that regulates imports and exports of products in order to safeguard domestic American industry, has imposed a 10-year ban on SK Innovation for the manufacture of machinery, raw materials, and refined battery-grade chemicals. Due to the lack of a domestic lithium-ion battery supply chain in the United States, the ban would have required SK Innovation to import all of its battery-grade essential raw materials, cathode and anode inputs, in order to manufacture their batteries, which the ITC would have prohibited. As a result, SK Innovation will have had to close the country's newest battery megafactory or gigafactory in Commerce, Georgia, which was due to start manufacturing in Q4 with an annual capacity of 10 gigawatt-hours, as well as delay development of a second 10 gigawatt-hour cell plant next door, a $2.6 billion investment. The Battery Day announcements are largely in line with our predictions for EV battery growth. If Tesla achieves all of its goals in this area, it will help to accelerate the adoption of electric vehicles, both for personal and commercial use. It's possible that the company's success would spread to other areas of transportation. Tesla, for example, would more than meet the vital battery density for short-range electric airplanes, 400 watt-hours per kilogram with high cycle life, assuming performance on all fronts. Elon Musk recently reported that this could occur in 3 to 4 years. Tesla's biggest effect will come from speeding up the adoption of electric vehicles and promoting clean energy. In other words, it will be pressing against an open door in addressing so-called quick-to-abate industries. Furthermore, its growth plans are in line with our projection, which is not quick enough as we infer. That isn't to suggest Tesla won't make a difference in the transition. However, how much depends on its potential to make a significant impact in the utility-level storage industry, as well as a second-order effect of spurring even greater growth of renewable energy sources, resulting in surplus energy being usable for an earlier scaling of electrolysis-based hydrogen generation than we forecast. We believe it is too early to render a judgment on Tesla's long-term effect on industries other than those that are easily mitigated. We welcome Tesla's efforts to reduce cobalt usage in batteries and to target the likelihood of reducing vast volumes of wastewater use from a mitigation standpoint. However, we warn that the planet will not be able to develop a way out of the climate crisis. Technology will definitely help us achieve the necessary energy transformation, but only if it is followed by bold policies and legislation, as well as behavioral changes toward sharing and circular economic models.